हेलो स्टूडेंट्स, इक्वेशन देखते हैं. देखिए राइट, इस क्वेश्चन में क्या है, स्मॉल ऑब्जेक्ट ऑफ यूनिफॉर्म डेंसिटी रोल्स अप अ कर्व्ड सरफेस विथ इनिशियल वेलोसिटी v and reaches up to a maximum height. Is this with respect to the initial position? The object बताना है क्या है, राइट. सो यहाँ पे इसकी राइट, यहाँ पे एनर्जी कंजर्व करा सकते हैं. तो लेट अस टेक दिस इज द इनिशियल पोजीशन हियर, and right, and after some time it goes up to here, let us suppose, and the height is given here. So let us say this height is given 3u square upon 4z, right. This is height. So I can, right, I can conserve the energy. So I can say k, right, k initial, right, or you can say like after energy conservation, right, after energy conservation, right, I can say, right, ke initial plus pe initial must be equal to ke final plus pe final, because the energy will remain conserved here. So initial kinetic energy is how much? See, first due to translational it will be 1 by 2 m into, it is moving with speed v, so 1 by 2 m into v square. I am assuming the mass to be m. Okay, so 1 by 2 m into v square plus the rotational kinetic energy is 1 by 2 I into omega square. So omega can be written like v, right, since it is having the pure, right, since it is rolling purely or it is having the pure roll, so you can say like in the case of pure roll v is equal to omega into r. So I can say like v upon r is equal to omega. So let us call this is equation 1. So using this equation I can write, right, the, right, rotational kinetic energy is right, will be equal to 1 by 2 I into omega square, that is nothing but v square upon r square. Okay, so this is the total kinetic energy. Potential energy I am taking, this is the reference line, so potential energy will be 0 is equal to final kinetic energy, right, when the ball will reach here it will stop, so here the kinetic energy will become 0, and potential energy will be how much? See, mgh, so that becomes mg, and the value of h is given 3u square upon 4z. Okay, so now you can see here I can write mg, right, g will get cancelled out from here first. Okay, now I can take this mv square that side, so let us take it. Okay, so here it, right, this side you will get, right, I v square upon 2r square is equal to, if you take this side, this, right, this will become 3, right, u square, this is your v square, right, my mistake, this is your 3v square upon g. Hey, this is nothing but 3v square upon g. So m, right, so I can, g has get, right, g is getting cancelled out, so I, right, so this will become 3 upon 4 mv square minus mv square upon 2. Okay, so you will get from here I v square upon 2r square is equal to, and you know, right, this was not u, it was v only, right. See here it is given v and the with same initial speed v, so this is also v and this is also v, mind it, right, so I v square upon 2r square, and this will become how much? See, right, this will become mv square upon 4. Okay, now this 2 will get cancelled out. Okay, and this v square will get cancelled out, and here you will get I is equal to mr square upon 2. So here you are getting the moment of inertia is equal to mr square upon 2. So the moment of inertia, right, whose moment of inertia is mr square upon 2, right, you know, right, you already know it is for the disk. So the answer will be D, disk. Okay students, I hope you understood this question.